Today we're going to use the space frame model to explain the secret of gravity. In last episode, I used space frame model to illustrate the relationship between time and space. Just to recap, we understand we live in a dynamic space. We experience time and movement because we're not in a static space. Space frames constantly pass through us at the speed of light. We are allowed movement simply because in each new framing pass through us, we can move a little bit. And we experience time because there's a large number of space frames pass through us constantly. More space frame pass us, more time we experience. Less space frame passing through us, we experience less time. That's why we experience less time. Time slows down when we approach the speed of light, because when we are moving close to the speed of light, we catch up with the moving space frame. Fewer space frame pass through us when we're moving very fast, and hence we experience less time. Now, the next part of the theory of relativity is the general theory of relativity, which deals with gravity. And Einstein stipulates that space and time bends at the source of gravity. Now, how do we use the space frame model to explain gravity? And that's what I'm going to talk about today. First, let's hypothetically go down to the basic, smallest unit of the time and space. Assuming these 5 dots represent the basic building block of our space. Now, we know that space frame pass through all the units, all the dots, at any time, at any direction, at speed of light. So from this dot, space frame goes out like this. From this one, goes out like this. From this one, goes out like this. Goes out like this. Space frame goes out, propagate out. Same direction, speed of light. Now, space frame, when they pass through you, they exert a push, a force of push. So this dot is the dot we're going to be focusing on. Now, this dot has the push of space frame from all different directions. Basically, they cancel out each other. That's why in the space, away from all gravitational sources, we experience weightlessness. We do not feel any gravitational pull from any side because space frame coming from all different directions cancel out each other. Now, assuming this is the gravitational source. Now, the gravitational source is a source with a lot of mass which prevents space frame from moving out. So from this source, fewer space frame will come out from this side. So this one, you have 2 coming out at a certain point in time, and from this source, only 1. So for the center point, there's going to be a net push of 1 space frame per second per unit of time from this direction. And this being a gravitational source, it appears that this one is attracting this point to the source of gravity. But in reality, because the gravitational source withholds space frame from coming out, and the net effect is there's more pushing from space frame from the other direction. And hence, we are attracted to the source of gravity. Now, let's look at a different scenario, which is things moving really fast at close to the speed of light. The basic construct of our space-time. When we're moving really fast to this direction, space frames coming out still at speed of light, but since we're moving close to the speed of light, these space frames will no longer look like circles. They will look like an elliptical situation because we move in this direction. Now, these 2 on top and bottom, they are kind of irrelevant because they still will cancel out each other. But for the center point location, there's going to be still same amount of space frame coming from this side to push that direction, but from this side, because we're moving over here, fewer space frame from this point will catch up to cancel out. So basically, it's same effect as if this point is a source of gravity. It will attract this point to over here. So faster we go, more attraction this point is going to exert to this point over here. So this point is going to feel a lot heavier. This point will gain more mass as we move along. That explains why when we speed up, things become heavier. It's the same thing as if this point was a source of gravity. Now, let's look at another scenario, our favorite subject, black hole. We have this supermassive black hole over here, all right? Black hole will suck in all the space frame. Not only it prevents gravitational space frame from going out, you'll suck in all the new space frame moving close to it. Outside of it, we have a sphere called event horizon. Event horizon is a distance from the center of black hole to a certain point where we achieve an equilibrium. At this point, no space frames will go in and no space frames will come out. So it will be perpetually a zero space frame move. Outside event horizon, you still have a little bit weak space frame going out this way, but you have more space frame going in this way, so that's why close to the event horizon, you still have a strong force to pull it towards black hole. But if you're moving fast enough, you can probably get around it. And when you are at the event horizon, basically, you have no space frame moving in or out. And that's why something at event horizon will experience zero time. It's just like as if you are flying at the speed of light. You are not flying at the speed of light, but at this point, you do not experience any time because simply there's no space frame coming through you. And that explains why the gravity, how the gravity works, how the gravity interacts with our space frame. We explained in the last episode that gravitational waves and light travel exactly at the same speed, at the speed of light. How come? They're totally not related to each other. They're not in the same family. We know light, radio waves, gamma rays, they're all in the same family. That's why they all move at the same speed. But gravitation is a total different animal. But surprisingly, it moves at the same exact speed. Why? Because they both just stick to the space frame as the space frame moves. And that also explains why we can never travel faster than the speed of light, because that's how fast our space allows us to move. We cannot move faster than the space, than our host. And that's it for today. If you have any questions or comments, leave a question and comment below, and I'll make new video to address those issues. Thank you so much.